Hi guys, I am Shepa and I am back with Maths XYZ, and today it's our last lesson on identities, which we have been doing ever since the beginning of the week. Alright, with identities, as I've already mentioned on the last lessons, that we have sin squared theta plus cos squared theta is equals to 1. This is just a reminder so that we can catch up from the last lesson. And today we will be doing more example on identities and see how we can approach different questions of identities. Alright, the first question that we will be doing, okay, I'll just write the identities down so that I can always refer to when we are answering questions. It's equals to 1, and tan theta is equals to sin theta divided by cos theta. Alright, the first question that we have to do is to simplify tan squared theta minus 1 divided by cos squared theta. Alright, when we are simplifying this, remember tan theta is an identity, and this identity is equals to sin squared theta divided by cos squared theta minus 1 divided by cos squared theta. Alright, then from here we can we have our LCM, which is common. It's cos squared theta. Then in the numerator we'll have sin squared theta minus 1 divided by cos squared theta. Our equation is not yet simplified. We can still continue on it. Let's look at our numerator, sin squared theta minus 1. Remember, from our identity, we can have cos squared theta is equals to 1 minus sin squared theta. Then from here, it's actually a reverse. What we need to do from the numerator is to take a common factor of a negative. Then we take a common factor of negative, and we'll have 1 minus sin squared theta, which now qualifies to be an identity. 1 minus cos squared theta is equal 1 minus sin squared theta is equals to cos squared theta. Now we'll have cos squared theta negative divided by cos squared theta, and the cos and the cos will cancel out and we'll only be left with minus 1. Alright, we have simplified the equation to its simplest term, which is equals to negative 1. Alright, from here, just a quick recap, we just changed the identity of tan to be sin theta divided by cos theta. And after that, after coming to this one, we realized that sin squared theta minus 1, it's not equals to cos squared theta. But then, cos squared theta is equals to 1 minus sin squared theta. What we did is to take out a common factor of a negative 1, and then so that we can have 1 minus sin squared theta to be equals to cos squared theta, which we have here. And then our answer, the cos squared theta cancel out, and we are left with negative 1. Alright, let's do another example on identities still. Alright, this example, it says that we must prove that the left-hand side is equals to the right-hand side. We must prove left-hand side is equals to right-hand side. On our left-hand side, we are given 2 sin theta minus 1, all in brackets, into sin theta minus 1, actually plus 1, divided by 1 minus sin squared theta. This must be equals to the right hand side of 2 sin theta, sorry guys, seems like I wrote sin theta minus 1 divided by 1 minus sin theta. Alright, proving from the left hand side, this is our left hand side, we have 2 sin theta minus 1 into sin theta plus 1 divided by 1 minus sin squared theta. What we need to do, because the numerator has already been factorized, we're going to be factorizing our denominator, which is a difference of 2 squares. Then from our left hand side, we have 2 sin theta minus 1 into, sorry, this is minus 1 into sin theta plus 1. Then from here in the denominator, we have a difference of 2 squares, of which we'll have 1, okay, a bigger space there. Alright, we have 1 minus sin theta and into 1 plus sin theta. Alright, then this one and this one will cancel out and we'll be left with 2 sine theta divided by 1 minus sine theta. Woo, okay, it didn't even take long and we have already proven that our left hand side is equals to our right hand side. Alright, therefore our left hand side is equals to our right hand side. We have proven it to be right, that our left hand side is equals to the right hand side. This was our right hand side and this is what we have simplified our left hand side to be, which is equals to the right hand side. Alright guys, let's do another example again on identities, which will be our last example. Alright, the question is still on proving that the left hand side is equals to the right hand side. And for this one we have our left hand side, which is 1 minus sine theta divided by cos theta. Alright, it's equals to the right hand side, which is equals to cos theta divided by 1 plus sine theta. Alright guys, proving from our left hand side, this is the first example of this kind, of which we cannot just prove from the left hand side or the right hand side, because everything is sine, it's cos, there is no cos squared or sine squared or tan or even an identity. So proving from our left hand side, what we're going to do is to multiply with 1 plus sine squared, 1 plus sine theta divided by 1 sine theta on the left hand side. So we have 1 minus sine theta divided by cos theta into 1 plus sine theta divided by 1 plus sine theta as well. Sorry guys, sine theta. We have multiplied the equation with this expression. We didn't change anything in the equation because we have actually multiplied by 1, because 1 plus sine theta divided by 1 plus sine theta is actually equals to 1. So we just multiply the equation by 1, which does not change anything in the equation. Then from here to we multiply in, we'll have 1 minus, this will be 1 minus, actually plus sine theta minus sine theta minus sine squared theta. Alright, and then in the denominator we'll have cos theta plus sine theta cos theta. Alright, this part here is equal to 0. Then in the numerator, that means that we are left with 1 minus sine squared theta. Remember, 1 minus sine squared theta is the difference of 2 squares. That means that we just have to factorize the numerator to have 1 minus sine theta into 1 plus sine theta, and divide by, taking out a common factor, it will be 1, it will be cos into 1 plus sine theta, of which 1 plus sine theta and that will cancel out and will be left with 1 minus sine theta divided by cos theta. Alright, we actually made a mistake somewhere. I made a mistake somewhere, which is from, this is 1 minus sine theta divided by cos theta multiplied by that, of which we got 1 minus sine squared theta divided by that, and we'll be left with, alright, I see why I made a mistake, guys. I actually didn't really make a mistake, it's just that I forgot one rule that we must actually apply so that we can get to the right hand side, of which, let's just erase this part. Alright, from here guys, 1 plus sine theta minus sine squared theta. This part, the sine theta minus sine theta, is equals to 0. That means that we are left with 1 minus sine squared theta. And remember our identities, cos squared theta is equals to 1 minus sine squared theta. That means that in the numerator we have cos squared theta. That's because I need a cos theta in the numerator. What I did by factorizing the difference of 2 squares, it was not wrong. But then the wrong part about it is just that I was going back to the question of what I did here, because here it was already factorized. Alright, then divide by cos theta into 1 plus sine theta. Alright, these two will cancel out and we'll be left with cos theta, because 1 cos is gone, divided by 1 plus sine theta. Alright, now it is proven that the left hand side is equals to the right hand side. Alright, what I did, and I said I made a mistake on it, it was not actually a mistake, but then if we have to come to the answer to prove that the left hand side is equals to the right hand side, we have to have cos in the numerator. Then to have cos 1 minus sine squared theta is actually equals to cos squared theta. Remember, with identities, there is a lot of ways of proving, of working out your answers. What I did was also right, but it was going to take a long route for me to get to the final answer. But then using this one, changing 1 minus sine squared theta and make it cos squared theta is the simplest way to get to the final answer, which is cos theta divided by 1 plus sine theta. Alright guys, I hope you enjoyed our lessons on identities. Just to recap from the first lesson that we did on identities, because we did identities this whole week, and then so that you can understand more on identities. Don't forget to subscribe to Maths XYZ so that you can get daily notification when we upload videos. As of next week, we will be starting with the reduction in trigonometry. Please stay tuned so that you can learn more from our channel. Thank you.